Hello! In today's lesson we are going to learn how to calculate the value of a number to some degree. But first let's remember why we need to do that. The thing is, we already know that we can write any number as a fractional number. For example, the number 2, I can write it down as 2/1 or 8/4, and there's lots of ways of doing that. But the thing is that the number 2, I can write it as a number of some degree, 2 to the power of 1. The question arises why we need this. The point is that large numbers we can write as a number to some degree, not all numbers, but most of the numbers we can write, for example, the number 1024, I can write as 2 to the degree of 10. And if the degree of a number is large, then it does not make sense to calculate the value of this expression. And so we can write some number in some degree. For example, if we have 9 times 9 times 9 times 9, 1, 2, 3, 4, 5, 6 times, then I can write down the value of that expression as a number to some degree and not calculate the value of that expression, but write down that this product is 9 to the power of 6. This is exactly why we will learn to find the value of some number in degree or write the product of some numbers as a number to a power. So we've written down that if we multiply the same number, in this case 9, 6 times, then I can write the value of that expression as 9 to the power of 6. If these multipliers are represented as letters, for example, A times A, multiply by A, multiply by A, multiply by A, multiply by A, and so on, 15 times. Then I can write this expression briefly as a to the degree of 15. Or if we see the expression a plus b multiplied by a plus b, multiplied by a plus b, and that expression is written 3 times, then I can write this product as a plus b to the power of 3. Of course, I can also calculate the value of the expression. For example, if I need to raise the number 3 to the 4th power, I can write that expression as the answer. But if I need to calculate, then I have to multiply 3 by 3, multiply by 3, and multiply by 3 4 times. Why exactly 4? The exponent of a degree is 4, so I'm multiplying the number 3 by itself 4 times, and the result is 3 times 3 is 9, 9 times 3 is 27, 27 times 3 is 81. Using the same algorithm, I can find the value of a fractional expression. If I need a fraction of 1/3 to the 4th power, then I have to multiply that fraction 4 times. The result is 1 times 1 times 1 times 1 times 1 times 1 times 1 is 1. But 3 times, 3 times, 3 times, 3 times, 3 times 3 results in 81. Note to self. The fraction 1/3 I need to raise to the power of 4, which gives me 181. But you have to be careful if you see the notation 1/3 to the power of 4. And this entry looks like this, so I'll end up with a fraction 1/3. Why does this happen? Well, the thing is that the notation has a big impact on the value of that fractional number, and we'll talk about that in the next lesson. And for today, our lesson has come to the end. Goodbye, see you again.